I'm James Linke. I own Michigan HydroGraphics Company, Incorporated. We're family owned and operated. I like to say if it's not in the shop, it's a hobby. We're a professional water transfer printing company. We've been in this location for 2 years now, and we've been doing hydrographics for close to 5. Our clients range from individuals with a single small part all the way up to corporations. We have a Kid Rock concept vehicle touring the United States right now that we did about 30 pieces on. My favorite part of the job itself, having this shop, is the people. I meet every walk of life, from everyday blue-collar guys like me to executive chairmen of the board of massive medical companies. And it's just awesome meeting all these people and the different walks of life and backgrounds. So it's very cool. For example, with Steelcase, Charlie got a hold of me by email. I looked at their product line and I couldn't imagine what he was bringing me because there's so much stuff, and he brought quite a few things. So the process for us is once we receive it, we write up the work order and we tag the product. We know how many parts are in a job, what the product is getting, the finish, etc., and what stages it's been through. Everything is washed and degreased 2 times before it hits the prep table. So always gloves, always clean gloves. I like to think we're a little more anal about it than even the food service industry. The painting process begins once the items are prepped. So you have to have a good bond from your primer to your substrate. You need a chemical bond from your primer to your base coat. You need to create a chemical bond from your print to your base coat, and then a cross-link chemical bond from your clear through the print to the base coat. This creates a unified coating that's never going to fail. It's not rocket science, but it is a science. Our parts have been prepped, primed, and painted. We size up the part and decide how big of a piece we need, unroll the film, tape it down, cut that off, and we lay it on the water. The average time is a minute. It's 90-degree water. That's allowing the PVA to dissolve underneath the film. Then we'll spray it with an activator, dip the part. Once that happens, we QC the print as soon as it comes out of the tank, put it in the rinse, runs over there for about 3 minutes. Shut that off, pull it out, QC it again. Once that's done, a quick freshwater rinse, and it's left to dry. Once it's completely dry, we move it back into the booth and clear coat it with whatever specified clear is required. HydroGraphics is an automotive paint process, therefore any of the special effects and effects that are done in an automotive paint job can be done using HydroGraphics. We can do 2-tone paint, we can do paint here and a pattern here. We have back lettering here. We can also do candies. Candies are a translucent paint, so you can see through them. We use candies as an effect. We can use it for color. We use it a lot for wood grain. We can also do other things like take this silver wood and make it darker. Same pattern, same paint, just a black candy on top before the clear. And there's thousands and thousands of patterns. Some of them are actually printed from photographs. Now this is a negative fire. The black is printed, which means we can put any color underneath it. We can match just about any color that's ever been done, whether that's by code or by doing a scan off the color itself. Once we have a color, once we've developed a color for a company, we can reproduce that color at any time in the future. We keep records as to what primer was used, what base coat, what clear coat, and if any candies were applied during the process. So we can make very realistic patterns, photorealistic, cartoony, whatever your graphic designer can come up with, we can end up getting it on a product. The films at this time all come from Asia. About 90% come from China and 10% from Taiwan. We can do a digital film at this time on a paper that we can do proof of concept with and very shortly we should have a complete US supply line, US printed gravure film. What made these chairs fun is the backside actually lent itself quite well to the HydroGraphic process. We used a 8H ceramic clear with a matte finish on it, so that's why we got good resistance, and it should patina well. The trick with this chair was the masking. This was hand masked, and this took about 40 minutes to get this line perfect around the chair. If we went into production with a chair like this, two things we would do for production is we would create a mask that we could put on the chair, it would lock to the edges, and we would run it. The second thing we'd do is build a jig that would fit a fixture for our dip arm that would dip the chair at the proper angle and speed. I think we figured out we would do 3 or 4 of these at a time per tank. For production and using the dip arm, the difference is repeatability. So once we R&D and figure out what angles we need, there's no more finagling. It's a steady speed and angle going into the tank. So I'll set the jig and the drop speed of the arm so that it goes in at a rate that it comfortably pulls the pattern into the part without any distortion or breaking. And it works great. When the parts first come in, like the parts you guys brought today, I have to decide what we can take in, what we can reasonably coat. This piece, although awesomely interesting, is going to create a problem. If this is 1 inch, you have a 1/2 inch here, a 1/2 inch here, and 1 inch there. So now you have almost 2 inches, but you've already cut the film going in. You have 1 inch of film to cover 2 inches of surface area. That's not going to happen. It's going to stretch and distort. So we would pick maybe an abstract sort of pattern, then it would probably need to be touched up in the lower recesses. So from a production standpoint, that's going to slow down your production and increase your cost. This is basically a perfectly printable part. So 45 degrees off the corner's not big enough to trap air going in, and it looks cast aluminum. So it's a substrate that's ready to be prepped, painted, and go through the process. It's absolutely lovely. We rarely see parts like this. When you actually go to do the print, there's a lot of variables at play, for one, and for two, as soon as you touch the film at any given point, the entirety of the film has to move. All the patterns are on a repeat. At most, you can do 1 meter, simply because the rolls for the gravure press are 1 meter by 1 meter. Now, if something's bigger than the tank, I can make a decision based on the shape and size as to whether or not we could maybe dip it 2 different times. If we're gonna do a car hood, we might come in, do 2 dips, and come in from either side and meet in the middle. So I couldn't do it in 1, but I could get it in 2. We do a lot of carbon fiber because of the motorsports. Very seldom is there a problem bringing the 2 together. The trick is making sure that you have the exact same amount of stretch and expansion when they meet. There are certain plastics that require more labor to prep. HDPE is one, polypropylene is another. Those require flame treating, which considerably increases the cost of the HydroGraphic process. Silicone creates fisheyes on a molecular level, and they make products that will get your paint to flow out over those. It's not a good habit to do just because you can have adhesion failures there. The fact that they're there indicates there's a problem. You need to correct it at the source and not treat the symptom. The rest of the plastics, ABS all the way up to the newest, most wonderful plastic ever, TPO. What people don't realize is that when you say plastic, that's like saying a beverage. And if you say TPO, that's like saying cola. So there's a lot of ways to make a cola. There's a lot of ways to make a TPO. So it's important for us to kind of know, and that's why we run our tests on every piece that comes in. Anytime we see we don't see a chemical bond, we reprocess. We want a chemical bond going out the door. That ensures our product's going to last.